are 46 people in this meeting. It's already 9:44. So probably others are still transferring from the old site to this new site, which we will be using every Wednesday already. Okay, I presented something on the screen already. By the way, can you hear me?
Yes, sir.
Thank you, Mike. Okay, so we'll just continue the topic that we stopped last time, and this time we will be focusing on stability of floating objects, and this is under the semi-submerged category. Uh, okay, again, we will be using here the Archimedes principle. I hope you still remember that one. Meaning, according to the principle, if the body is immersed, then it is buoyed up or subjected by an upward force, the amount of which equals the weight of the liquid displaced. But our focus now is on the stability aspect of the floating object. Now the figure, I believe, still very familiar to all of us. Okay, just to refresh the different important points. Now we have here the G, where the G refers to the center of gravity of the floating body. So that's the center of gravity. Now the BO is the center of buoyancy, meaning this is the center of the submerged portion. That's where you apply the buoyant force. The weight of the floating object, you apply it at point G. That's the center of gravity. And what will happen if you tilt, if you disturb the floating object such that the position is now the figure on the right side, the angle of tilt is indicated theta. And in this particular position, the floating object is in the state of equilibrium, meaning it will not continue to tilt and it will not also return to its original position. We consider this position and the object is considered stable. The center of buoyancy will shift to another location, but the center of gravity remains the same because the the cargos are in place. No, the cargos are not moving. So in the event that cargos will be moving, then might be that the G will also change. So that's the assumption. No, the floating object, which is in this case the ship, and the cargos are intact or properly tied, no, so that they will not shift or transfer from one location to another location. If we are going to project BF vertically, it will intersect with the axis of the floating object. And that point, we call it as the metacenter. That's M. And the distance from M to G, we call it as the metacentric height. The theta is the angle of heel or angle of tilt. So in most cases, the calculation is the determination of mg. Okay, so metacentric height mg is calculated as mbo plus minus gbo. So if we go back to the figure, the bo may not be necessarily below the g. So there's a possibility that the bo would be above the g. Okay, and if that's the case, then might be that the object is very stable. No? Well, the mg is calculated as mbo, then you subtract the gbo. But in the event that the bo is above the g, then the mg is calculated as mbo plus gbo. I hope that's clear. Now that's why we have the value here plus minus. Use plus if the bo is higher than the g, and minus if the bo is lower than the g. If mg is positive, meaning if the bo is higher, no, if the bo is always higher than the g, because we will use plus, then the mg becomes positive. But if the mbo, if the mg is minus, so there's a chance that the gbo is greater than the mbo. So that is, if mg is positive, the body is stable, while if mg is negative, the body is unstable. And if mg is zero, the body is in neutral equilibrium. So if we go back to the figure, let's entertain mg, which is negative. So if it is negative, it means to say that the bo is, okay, because the mg is calculated as mbo minus gbo. So there's a possibility that the mg is smaller than the gbo. You look at the mathematics, no? So mbo minus gbo. You can have a negative result if the gbo is greater than the mbo. And if that's the case, the body is unstable. Okay? Now, the formula for MBO is calculated as I. I will not present the derivation anymore. MBO equals I over V, where V is the volume of the submerged part of the body, while I is the moment of inertia about the axis of rolling of the area defined by the water line. And the theta is already defined earlier. In most cases, the value theta is relatively small. So if this is small, then this one will disappear. And if that's the case, the MBO is calculated as I over V. So mga hint nga you can use I over V kung ang expression is what is the initial, no? What is the initial metacentric height, things like that. Anyway, I will also present a sample. So the sample here, a barge 6 meters wide, 18 meters long, then 2.4 meters high, is loaded with junks as shown in the figure. The center of gravity of the barge and its cargo is located at G, which is 2.4 meters above the bottom. The combined weight of the barge and cargo, 1998. So nigawas ni pag 1998 man sa kilonewtons, and the unit weight of seawater is 10 kilonewtons per cubic meter. Now determine the initial metacentric height of the barge. So take note of the term initial. If the barge is tilted to an angle 15 degrees, what is the maximum moment produced by the buoyant force? So we are interested the draft, letter D, okay, determine the initial metacentric height. So we should be determining the draft, and defined last time, draft means the depth of submergence. Now, the weight total must be equal to the buoyant force. That is the reason for this equation, where the buoyant force, I guess we still remember, it's calculated as the unit weight of water, multiply it by the volume submerged. So in this case, the volume submerged is 6. That's the base. This is the length. And this is the depth submerged. Multiply it by the unit weight of seawater, which is 10 kilonewtons per cubic meter, as given in the problem. Therefore, the draft is 1.85. Knowing the draft, we can now calculate the center of buoyancy, because the figure submerged is a prism, meaning the rectangular prism. So the centroid is exactly naa sa center of the rectangle, meaning it is located at D divided by 2. This is the formula for the MBO, the distance from M to BO. And because we are interested of the initial, then we don't use the tangent square of the angle. So the angle there is 0, initial. That means tangent 0 is 0. We just use the I over V. The I, if you look at the figure from the top, this is the appearance of the barge. This is the axis of rolling. So the barge will roll in this direction, then go back. So this is the axis of rolling. Now this one here is the axis of pitching. So if you look at the side view, mag-side view ta sa barge, yung naanang nga barge, travel siya paingon dito. So possibility about this axis, ang barge mo rotate in that direction and go back in that direction. That is what we call pitching. And this is the axis. This is the axis of pitching. This one is the axis of rolling. Ini sa pitch ni siya. Meaning, the moment of inertia is calculated as the base. Ang base is always the dimension parallel to the axis. So the base will now serve, the L will now serve as the base, because this is the axis of reference in calculating the I. I hope that's clear. So the base, multiply it by the cube of the height for the rectangle, but the height is the B. So LB cube, then the volume submerged is LB draft. Okay, over 12, because the formula for moment of inertia is 112 base times the cube of the height. So you can remove the L, you can remove B. This one will become square. So finally, you have B square over 12D. That means the MBO equals 1.62. Since the BO is already known, diba? The BO is the center of buoyancy, and the MBO is 1.62, meaning from here up to there, inertia is D over 2. Ang kana siya is 2.4 minus the D. Ka-follow ta, no? Yeah. From here, i-locate na to ang M by utilizing the MBO, which is 1.62. So, asa man na mo asa man na mo malocate ang M. So 1.85. So 1.85 divides sa nato 2. That gives us 0.925. Ini siya 0.925 ni. Kini nga distance equals 2.4 minus 2.4 minus 1.85. The result is 0.55. Plus 0.925, that will give us only 1.475. Kini siya 1.475. But M is located 1.62. So meaning, ang distance from G to M, that would be 0.145. So the metacentric height in this case is positive, no? Because you would say MBO, this is now the BO, minus GBO. Okay, so 0.145. 1.475. 2.4, sorry, 2.4 din. Okay. So, I hope na what tayo problema ini, no? So that would be ang GBO is 1.475. So ang MG is now 1.62 minus 1.475. The result is 0.145. So unsa may atong judge, is it stable or not? Data ni David Gabriel. David, are you there? Hello?
Hello, sir.
Stable, unstable, or neutral equilibrium?
Since the MG is higher than wait sir, nakamabot ko sa conditions. I guess for me, sir, is stable.
It
Or
is stable. Nganong stable man?
kind of confused sa conditions, sir, pero like if MG is higher or positive, it is stable.
Okay, so if MG, but would you agree? Would you agree on that? Stable siya. If you use your common sense, is it really stable? Ana na siya, no? Ang reasoning, mo ni siya ang M. Mo ni siya ang BO. Kini siya mo ning G, center of gravity. Are you still there, David? Hello?
Yes, sir. Naraka, sir.
Ha? Sabi ko nisibat na sabka.
Wala, sir.
Okay, so ingon ini, no? Everybody, I think you need to pay your attention here. This is the weight. Kini siya mo ni ang BO originally. This is the buoyant force, BF. Okay, pag tilt, when the object is tilted, ang BO will transfer here. Muna ni ang BO prime. Meaning, kining buoyant force will also transfer here. Since it will intersect with the M, so tanaw nimo ang duha ka forces, kining nga force o kining nga force will tend to restore. No? It will tend to restore the floating object. kung imong tan-awon ang moment nga iyang ma-create, paingon man dito. Klaro? May mata na taglain kung klaro ba. Si Tia Binuisa. Kami, Fit Ben. Dito.
Hello, sir. Klaro ra, sir.
Klaro ra, no?
Yes, sir.
So, klaro siya nga matawag na tog stable because there is a restoring, no? There is a restoring moment. Iyang i-restore ang original or ang tilted na position so that it will go back to the upright position. Pero kung imong tan-awon ang situation, kung tan-awon nato ang situation where the MBO or the MG becomes minus, I will use another figure. Dire ko nga figure, no? So, if the body will tilt like this, so this is now the axis of the floating object. Assuming that the G is here. No? So, mo nang sa Cebuano pa nga term, tumbalubo ang imong cargo diyan na dire, no? Mo nang ang center of gravity is here. And then the MBO is here. Mo ni ang BO. Pag tilt, ang BO mo shift dire. Pag shift niya, mo na ni karon ang buoyant force. Kini siya mo ni ang weight. So ang weight is applied at the center of gravity. So kung imo ni siyang i-project down, diara ang iyang projection. So there is a distance between the two forces. And as you can see, these two forces will create movement in that direction. So the more the body will tilt, di siya maka-recover. So in this particular case, ang atong M, by projection ramana sa buoyant force, so the M is here. So as you can notice, the MG is calculated as MBO minus GBO. No? So M, this is the M. And if you calculate MBO minus GBO, you will notice that it is obviously negative because MBO is smaller than the GBO. Klaro? I hope klaro na siya. So atong ipa-confirm kung klaro ba ang duha ka cases, unstable o stable. Si Madeline, how about Madeline? Madeline, are you there? Hello, Madeline. Question na si Madeline. Iyalang na ako na sa stable. How about Eunice Kyle? Eunice Kyle. Hello, Eunice. Eunice Kyle. Nagyapon. Naglain. Si Aidan Troy.
Yes, sir. Klaro ba?
Klaro ra?
Yes, sir.
Si Nicole Alexi.
Sir.
Klaro ra?
Yes, sir.
Kaya klaro ra gyud ha? Di na gyud ta negative ini sa mga exams na to. Ay, klaro naman. Okay. So, ang MBO pag tilt na sa object, okay? That's the MBO is now calculated as I over V, where ang I over V already calculated earlier, itong 1.62. Yeah, 1 plus tangent square angle, 15 degrees man ang angle of tilt. So the result is 1.678. And if that's the case, the mg becomes 0.203. So as you can see, it is stable. And the righting moment is calculated. So how do we calculate the righting moment? You just determine the couple. Couple means rotation produced by these two forces. So it's equivalent to, you can utilize the BF. This is the BF. And you take moment about the G. No? Take moment about the G, meaning you will be needing this distance. And how do we calculate for the distance? You utilize the mg. That's the mg. So the mg, and then multiply it sine angle, where the angle here is the angle theta. Clarex. So the result, we call it righting moment, 104.975 kilonewton meter. Any question or clarifications?
Sir, pwede mo ask, sir.
Yes. of
Unsa
course.
na unsay basis sa pagpili sa moment of inertia, sir? Di ba naman to'y duha ka types, katong rolling og sa katong pitching. So ay mo base mo example, sir, marag ay nganong katong pitching ang imong gigamit, sir?
Dili man pitching ang gigamit dire, ang rolling kay.
Ay rolling day.
Kung mao ni siya ang imong i-investigate, rolling man ang siya, di ba? So kini ang axis mo imong basis. Mo ni ang L, mo ni ang B. So kung kini nga axis, parehara nag-analyze ka og beam, nga ingon ana, nga mo ning neutral axis sa beam. So kini siya mo ni ang B. The B is always parallel to the axis. Okay? O niya ang height, mo na ang dimension perpendicular to the axis. Now, because ang atong gi-consider dire is the tilting man, angle of tilt. So problem, tilting. So tilting meaning it's rotation about this line. Pero ang pitching, bang sa ako nang i-illustrate ganiha, kung mauni ang barge, kanya mo travel ang barge dito, na may movement nga ang barge mo rotate about ining axis. Mo ni ang L niya. So kung ang iyang rotation ingon ana, ang dunggo na siya sa mga waves. Diba? So ang iyang movement, saka, ubos, siya. That's rotation about this axis. That's rotation about an axis perpendicular to the direction of the barge. Mo na pitching na action. So kung pitching ang imong investigate, you will be considering this axis perpendicular to the screen, or kung imong tan-awon sa top view, dire ka about ining axis ang imong i-consider, because you are investigating movement about this line. So, kini na siya mo serve as base, kini na siya mo height. Klaro?
So kung kanina problem, sir, kay permi na siya, permi mag-consider sa ng katong rolling, sir.
Kanang term nga pirmi mag-consider, dili yun na siya, no? Kaya kung ang problem is about pitching, pitching sa imong i-consider.
Possible po na, sir, sa board exam, sir, na ang pitching ang basehan.
Yes, nganon di man possible. Simple gihapon.
Okay, sir.
Yeah. Okay, so next ngarita sa hoop tension. Atong i-review gamay ang strength of materials, no? Kung tagaan tag tank ingon na nagporma under the topic thin-walled cylinder, unsa may mga stresses nga ma-experience ini nga tank kung mo contain siya og liquid with certain pressure. So pressurize, ang internal pressure, we call it P. This is internal pressure. So unsa man tong duha ka klase nga stresses or ang duha ka klase nga mode of failures na si internal pressure. So atong i-recall lang ang topic ninyo sa strength of materials na thin-walled cylinders. Kaya mangutana ta ni Albern.
Yes, sir.
Yes, unsa may imong mahinumduman? What are the two types of stresses na ma-develop sa thin-walled cylinders?
Katong tangential manguro to, sir, og kuan.
Usa tangential, the other one is
Kalimot ko sa sir.
nakalimot na. Siguro si Alessandro, may maka-remember sa usa. Alessandro, minus Alessandro, kay utakan man ni siya. Problema kay wa siya. Wa si Alessandro. Hello, Alessandro. Nauna kag bakasyon na mo, Alessandro. Bakasyon na guys, Alessandro. Ayan, computer lagi pa attend. Si Alexis. Yap.
Wasad ko
Yes,
pinumdum
Justin.
sa usa, sir.
Wa kinumdum sa usa. Justin,
Search ka na.
Natag theory of structures niya, di sa kay kinumdum. Si Christian, yeah. Christian,
Nakalimot po ko, sir.
ay nakalimot sab siya. Kini wag ni kalimot si Dayan. Duhagod ka account gamit Dayan.